Hey guys, so today we're going to go over implicit differentiation, which is used to express y as a function of x explicitly. Makes sense, right? So I'll go over it with the example just to kind of clarify a little bit. So I'm building up to it with the first couple of examples and then we'll step it up. So if you look at example 1, it states to derive the function with respect to x. Makes sense because this is x to the third power. So I'll just derive it as usual using the power rule. 1 times 3 is 3, and then take 1 away from the power. So nothing special about that. However, in number 2, notice that it doesn't match. So I'm being asked to derive the function with respect to x, but my function is not in terms of x, it's in terms of y. So I'm still going to derive it using the power rule, which gives me 3y squared, but to note that it was derived explicitly, at the end of it, I'm going to put dy over dx. So what happens when you have a little bit of number 1 and 2 in the same function? So if you look at number 3, the first terms are separated by plus and minus signs, remember. The first term is not going to be difficult to derive. I derive with respect to x, and the first function is in terms of x. So the derivative of x to the first power would just be 1, and I'm just going to create a sidebar here. So remember that 1 times 1 using the power rule is 1, and if I take 1 away from the power, it would give me x to the 0 power. Anything to the 0 power is just 1, so bring down this 1. 1 times 1 is just 1. And then plus, the second term, however, is not in terms of x, so I can't derive with respect to x. Instead, I will derive with respect to y, noting that I did by putting dy over dx on the end like last time. So I'm going to use the same power rule. 1 times 3 is 3. And if I take 1 away from the power of 1, it gives me 0. Anything to the 0 power is 1, so it's just 3. And I'm going to note that I derived it with respect to y by putting dy over dx at the end of it. Okay, so what happens when it's not separated by a plus and minus sign and I can just derive each term separately? What happens when it's just one term and it's in terms of x and y? So this is where I'm going to kind of make it like a constant. So meaning, I'm going to derive with respect to x. So I'm going to treat y squared in the beginning like it's just a number, like it's just a constant. I'm not deriving it, so I'm not deriving anything with respect to it. So it's just going to go on the outside like a constant would. And then I also have to derive the y. So now for the second step, I'm going to treat the x like it's a constant. And I'm going to note that I'm supposed to derive with respect to x, but it's just y squared. So looks a little bit more difficult than it actually is. You're just doing what you did before, but all in one problem. So for instance, I'm deriving the x, the derivative of x is just, we already did this, is just 1. So this is y squared. I'm just going to bring that down, and the derivative of x is just 1, which just gives me y squared. And then plus, I'm going to bring down the x like it's just a number, like it's just a coefficient. And I'm going to derive with respect to x the y squared like I would in the other problem, which would give me 2y, noting dy over dx. So from here, I'm going to clean it up a little bit with the second term, so that will give me plus 2xy, we usually see our variables multiplied in alphabetical order, times dy over dx. There is a reason for implicit differentiation, but I'm just teaching you the technique in the first video. All right, guys, I hope this helps.